Welcome, everyone. This is another series of our Pathways podcast where I talk to scientists or people in a STEM career and talk about their pathway into their career. Today we have Dr. Marsh, who is a paleontologist at the Petrified Forest National Park in Arizona. So first of all, thank you, Dr. Marsh, for being with us today.
Thanks for having me. I'm excited.
So I'm going to give a little bit of a background of, what I know of you, and just a little bit of disclosure here. I do know you a little bit outside of just daily life. We met a couple years ago. I was a part of the Dig Field School that was visiting the Petrified Forest, and I think it was 2024.
Yeah,
it was either 2020. I think it was 2024. Beginning of June, we met. And I have to admit, before I introduce you, So anyways, we do know each other. I took something from you. There's a photo of something I took your saying "crock a clock." Like, that is now something I use daily out in the Hell Creek Project. You said it down at the PIFO, and I took it. I was like, I have to share this because I use Crocs all the time. So thank you for unknowingly giving me that little tidbit of.
I'm either in hiking boots or Crocs. That's it.
It's now like one of my calling cards, and I kind of feel back. I was like, oh, I took that from Dr. Marsh.
No. It's
but anyways, so
fair game.
So Dr. Marsh, you grew up in Granger, Indiana, near South Bend. That means that you chose to go to University of Notre Dame. You got your bachelor degree in biology, and then you went on to the University of Texas to receive your master's and your PhD. Is that correct?
Yep, that's right.
In specifically geology. I watched another podcast where you talked a little bit about your internship, which I want to dive into, but you got an internship at the Petrified Forest National Park back in 2013. And now you are one of the lead paleontologists at that park. So I want to definitely talk about that transition of how did you get that internship into, and then getting the lead paleontologist career. But now you specifically research, and you have specifically researched early dinosaur evolution and stratigraphy of the Mesozoic rocks of the Colorado Plateau. Is that correct?
Yeah. Mostly the early Mesozoic, Triassic, Jurassic.
Perfect. So I think I've covered everything. Is there anything you want to add with your kind of background or things that you do just like as a career focus?
No, other than to add that, I do have the pleasure of being the lead paleontologist out here, but a lot of us wear different hats. So I also do things like environmental compliance, wilderness management, all kinds of other things too. Everything kind of is very well integrated out here.
I feel like with what I've talked to with national park employees, you have to wear those kind of many hats of, just the dynamics of your job.
Yeah, definitely.
Well, I want to jump into, before I get into any further, because I don't want to forget this. I have to start out with this. What's your favorite dinosaur and why?
Chicken. I like it fried.
Chicken.
Yeah. No.
That's a perfect response. I love that response.
Extinct lineages, Dilophosaurus is kind of, got a special part in my heart. It was part of my dissertation, and, it's from the Navajo Nation, which is, borders us to the north, and it's a neat animal.
Mm-hmm. What time period did Dilophosaurus live during?
Early Jurassic. So about 190-ish million years old.
Perfect. Okay, so I just want to keep that as a tradition of starting, even when I don't talk to paleontologists, I want to ask that question. So let's jump into the kind of the background of where did your kind of love of science first begin? As a high school student, middle school student, did you start, thinking about a science career? What just led you down the path of a STEM career?
It's really tough to say. I've always been fascinated by dinosaurs and other extinct lineages. So there's not like one aha moment that I can pinpoint and say this is when I realized I wanted to do this. I've always wanted to do it. Like I told my preschool teacher, I'm going to be a paleontologist. And since then, we've my mom ended up working with her, and so she's been able to follow my career and see that I managed to do it somehow. But I spent a lot of time outside when I was a kid. My brother and I were in Boy Scouts, and I always valued outdoors time and natural resources and scenery. And but one of the things that I can credit sort of that transition from like a childhood fascination to, hey, maybe I could do this for a living, is a paleontologist that I met when I was a kid. Do you remember when like there would be these traveling robotic dinosaur exhibits that would go to like malls? You'd go to a mall and then there'd be rah, rah, all that. And then so there was this paleontologist named Keith Rigby Jr., and he was the only paleontologist that I had ever seen in the newspaper. He was actually at Notre Dame, and he worked on Cretaceous and Paleocene questions about dinosaur extinction and mammal origins. And at the time he was kind of in the news because he was excavating this dinosaur, Peck's Rex. I don't know if you're familiar with that individual of a tyrannosaur from Fort Peck. So I'll spare you the details, but he was in the news for that. And so I met him at one of these robotic dinosaur things because he was giving a talk, and he signed my little dinosaur book, and so that was like my introduction to, oh, you can actually do this, as a job. And of course, Jurassic Park, was a big thing when I was a kid, and so like, oh wow, action hero paleontologist. That's definitely not what I do, obviously, but so yeah, when I then fast forward a couple of years, I was in 8th grade and we had to do a career study project. So I called up Rigby and I said, hey, I met you a long time ago when I was a kid, and I want to be a paleontologist, and can I interview you? He goes, I don't do interviews. And I'm like, well, I'm a kid, like I'm in 8th grade, like it's not like I'm the media, can we have a couple minutes to sit down? And so finally he's like, yeah, I have a half hour next week. We can do that. And so my mom drove me to campus, and we sat there for 3 hours talking about paleontology and what you would need to do as a young kid, or not a young kid, but like going into high school. What classes do you need to take, or what kind of trajectory would you need to go biology, geology in college? And so we had this great conversation. And so, Rigby, I'd really like to go to Notre Dame. I grew up around here. My dad went here. I love campus. It's a good biology, it's a good school for biology. Why wouldn't I go here? He's like, well, yeah, when you get here, if you get here, let me know. So when I got in, one of the first weeks I was there, I knock on his door, like, hey, Doc, it's me. And so he kind of became this unofficial mentor, and actually took me out to do some of my first field work out in Wyoming. And so to answer your question, sorry to get back to it finally, is that, like I said, just that over many years, that interaction with a mentor early on really, again, helped me kind of convert my, kid obsession into a way of thinking about the world and what it is, but how it came to be through, fossils and past life. So I owe a lot to that kind of relationship, and I try to bring that into what I do here, whether that's, outreach and interpretation with our visitors, or hosting internships, or supporting my staff. Like those especially early relationships and early kind of conversations can change somebody's life instantly, and you don't really know it until you look back 20 years ahead in the future, and you're like, wow, that was important.
I love hearing, and when I talk to scientists, I hear this. I feel like so much. I love hearing the soft skill of just networking and how important that is, not just in science, but just in any aspect of life. Is just reaching out, putting yourself out there. Those connections just really mean the world. I mean, especially for your case, that just sounds like what we're talking about with when I talk to students. Like, build that soft skill.
Yeah, and don't be afraid to be vulnerable and ask questions, right? Like,
One of the things I'm going to come back to here, Boy Scouts. I did not know you were. Maybe I forgot you were in Boy Scouts. I have to ask. Did you get your Eagle Scout?
I did. Yeah, my brother and I both did, and my dad's
Yeah.
Eagle
Yeah.
as well. Yep.
Ah, so my brother and I both were Eagle Scouts or are Eagle Scouts as well. My dad was the Scoutmaster as well. So I feel like we probably live very similar lives. Just growing up, being outside,
Yep.
like you said, wanting to be paleontologist. So I'm going to jump into your kind of. I mean, you went over a lot there, which was amazing. You went from high school to college, and obviously having that professor there and just having that kind of outlook on life, you jumped into paleontology through that course or through that major. What was your time like at Notre Dame? You talked about it was it's a good school for biology. What classes did you take? Did you try to? You said you went into your undergrad knowing you wanted to be a paleontologist. However, you got your degree in biology, which is what a lot of scientists do. But do you want to talk a little bit about your experiences? Did you do any undergrad research there? You talked about going to the Cretaceous area in Wyoming. Is there anything else that you did in college that kind of set you up for your career now?
Yeah. So to give us a little bit of background, Rigby was kind of my in-state mentor, but I was also, this was like the golden era of Yahoo Mail. And so I got my first like email address, and I emailed Jerry Harris, well, he just retired. It was Dixie State College, and now I think I can't remember. It's in St. George, the university there. And then shout out to Jerry. And then I also emailed Matt Lamana at the Carnegie. And so I was asking, like, when I'm about to go to school, should I focus on biology? Should I focus on geology? And they both gave kind of similar answers and said, it really depends on your interests and what your eventual, research would look like. But take all the math you can, take all the science you can, take writing classes, and stick with it. So I decided that I was a major in biology, and then I minored in geology, which is actually how I met my wife, who was a major in geology, and now she claims to not like rocks. But every time we're outside, I prove that she actually is still fascinated by rocks. Notre Dame's biology program is kind of twofold. One is focused largely on a pre-med kind of tract, and the another one is sort of a modern ecology, lots of like aquatic ecology and forest ecology and things like that. So I was the odd dude who was taking all these classes with pre-med kids, who then was also taking geology and the evolutionary biologies and comparative anatomies and stuff like that. So I feel like since going to my undergrad have tried to have like a foot firmly in geology and firmly in biology, because I didn't know what my research interest was going to be, and now it's all over the place, and I'm glad that I have at least some passing knowledge in most things, and can go from there. I wish, for those who are watching this and want to be paleontologists, I wish I took more things like coding and R or Python. I'm very rudimentary when it comes to like technological mathematics and things like that. But that's what co-authors and colleagues are for. But like I said, if somebody's interested in being a paleontologist, those kind of skills are really, really important these days, and they weren't something that I was focusing on, I guess. But so Rigby and I and another kid who was interested in paleo went out to property near let's see, Osage, Wyoming. It's a Morrison Formation unit that I think University of Kansas used to dig at, and it's a property that's owned by a citrus farmer in Phoenix named John Babiars, who he's a huge fan of like Paleocene, or not Paleocene, Cenozoic cats, and so he had some property, and we dug up the butt end of a Camarasaurus for, a week and a half and did some microvertebrate screening. And then swung by Provo. His family, his dad actually, Rigby's dad was the foremost expert on fossil sponges. Like when you see those big blue volumes on the treatise of invertebrate paleo, like he's Mr. Sponge.
Mhm.
So I got to meet him and saw the museum in Provo, and then we swung, by and came back home. But that was really interesting, and it really again opened my eyes. Like, wow, this was so I really like being outside and doing this. Like this was a lot of hard work, and it was fun. Um, then I volunteered for 11 weeks for Museum of the Rockies, a graduate student named Elizabeth, who I think is now at the museum in Dickinson. Um, she was digging up a bone bed of Griposaurus in Rudyard, Montana, so like far northern central Montana, and it was a lot of fun. I lived in a tent for 11 weeks and I loved it. It was just one of the greatest experiences of my life, and again, really cemented like, well, yeah, this is exactly what I want to do. So aside from that, though, Rigby was not really doing any research anymore, so it wasn't like there was an opportunity to do any paleo at Notre Dame. But I worked for a professor named Peter Burns. Actually, my wife and I both at the same time, which obviously, I don't even think we were dating while we were working there together, but we were working on actinide crystal chemistry. So he works on uranium, neptunium, plutonium minerals, and what we were basically doing is pipetting at standard temperatures and pressures and benchtop pHs and things like that. We were pipetting uranium or thorium with in all kinds of combinations of other solutions to try to create these novel uranium minerals, in effect to simulate what could happen if something like spent nuclear fuel leaked out of a geologic repository, right? So trying to predict what we could expect chemically if there was some kind of leak in a geologic repository. And then some of that work was also related to looking at efficiency and processing of or reprocessing of spent nuclear fuel. So, running it through the system again, because nuclear power plants are notoriously inefficient with respect to how much uranium is actually, fissions. So, anyway, I'm fascinated by nuclear chemistry and nuclear physics. So that's like when I go home and read a book, that's usually what it is. It's not anything related to fossils. But yeah.
You keep that in your day job time.
Yeah. But I mean, there's still echoes of it in some of my research. When I did a bunch of, like uranium lead dating, and I was doing some investigations for my master's on the chemical component of fossil bone. So like using laser ablation, inductively coupled plasma mass spectrometry, and so fun stuff like that.
So something that I'm hearing, and I love when scientists, talk about these experiences, is especially early on in your careers, in your education, in undergrad and your masters, you're trying out these things. You're going to experiences like you talked about going to Rudyard. These things are, I think, great ways or great experiences for people to realize, hey, I either really enjoy doing this or I really hate doing this. And you talked about how you absolutely love that. I think it's important that students realize that, like, yeah, that's what undergrad's for. It's for generalization, and yes, you want to start getting focused towards the end, but it's for those experiences. Whenever I hear students say like, oh, I didn't like this, I'm like, that's great, that's fine, that's part of the journey. So I love hearing that you talked about that.
Yeah, definitely. When I talk to like interns or staff, that's exactly kind of how I phrase it. Your undergrad is for meeting people and having those experiences and learning how to function as an adult, right? If you want to go in and people ask me like, well, should I get a master's after that or a PhD? And it's like, well, I feel like there's not a lot of paleo oriented undergrads. So like, unless you're able to do something like a undergraduate thesis that's being sponsored by a faculty member or something, I you know, that's there's those opportunities. But your master's is then there to create that tool set, right? That kit that you can then go on and use on a job, or use then towards a kind of directed question in a PhD, right? So yeah,
Yep.
like you said, especially the scientists, like, negative results are just as important sometimes as positive ones. Those same with experiences, right? Like, you need to know what you don't like just as much as you know what you do.
Yes, 100%. My whole since being with the dig program, my whole aspect or view of science has really changed. And you talked about the negative results meaning just as much as the positive ones. Yes, totally agree. When you were in your, so from going from your undergrad to your master's, you said you specifically got it in geology at the University of Texas. Why did you choose that route? I mean, obviously you wanted to go into paleo, but was there anything from the University of Texas that really drew you into that program?
Yes. So the project that I was really interested in working on was this description of a early long neck dinosaur from the early Jurassic called Ceratosaurus, and it was from the Navajo Nation. So when I was visiting now there as a prospective student, you know, talking to my would-be advisor, I just absolutely fell in love with their collections and their lab spaces. Some of the most important early Jurassic collections are in that location. The Navajo Nation, you know, there's incredible outcrop of Permian through, you know, Cretaceous and above, all throughout the Navajo Nation is a big area with a lot of great rocks. But that early Jurassic collection from the Kayenta Formation was really something that was like, wow, there's a lot to do here, and there's a lot of, you know, really cool things we could think about and ask questions about. So I kind of look back on my master's, which was a fairly straightforward anatomical description of a dinosaur. But then I took it a little geochemically and asked some other things. But I always kind of look back and say, yeah, that actually raised more questions than it answered. So that's why I stuck around and did a PhD and expanded on that and tried to answer some of those questions. So that's, you know, a lot of folks, if they do a master's, will go to do a PhD somewhere else. But I wanted to stay and continue working on some of those things with that collection, with that in that facility, with those staff members and faculty members. So yeah, Texas, those collections are spectacular.
I'm sorry to react whenever you give an answer, but there are certain phrases that I love, and I feel like I didn't prep you for this, but I swear I didn't ask you to say this. But when you talked about your research, asked more questions than it really answered. I love that. I think actually I got that from I know we have a mutual friend, Dr. Greg Wilson Mentia. He said that once, and I was like, I love that, where good science raises more questions than it answers. And I love that aspect that you just shared.
Yeah, it's like a positive feedback loop in itself. It's like a fission reaction, right? Like, to go back to my my actinide alter ego.
Yep. So you did so your undergrad, or I'm sorry, your master's was focused on the Ceratosaurus. Mm-hmm. Was your your PhD, was that on the Dilophosaur then? Then you kind of went away, or was it just a continuation of your Ceratosaurus?
Yes and yes. So there were two individuals of Ceratosaurus, the holotype specimen and the paratype, that came from the same hole in the ground that also contained a Dilophosaurus. Really well preserved, partially articulated. It's a really cool site. So, you know, there's Dilophosaurus as like, I think I described it one time as like the world's worst known dinosaur, because there's all these things about, well, did it have a frill? Could it spit venom? You know, how big was it? And part of that is is the chitinization of the dinosaur because of Jurassic Park, and but also when you look at the specimens, like the holotype and the paratype and another specimen from near Tuba City that are at Berkeley, are spectacular, and they were described decently in like 1984 by Sam Wells, but you really needed more figures. Some of the anatomy needed some anatomical descriptive updates, and then the new specimens that were at Texas then provided some more light on the unknown anatomy or the little known anatomy. So one chapter was kind of doing a complete overhaul on Dilophosaurus. Another chapter was a similar description of the holotype specimen of Chindisaurus, which is Petrified Forest's resident dinosaur celebrity. And then two other chapters then were looking at uranium lead ages of the Chinle Formation and the Kayenta from a lot of different spots. So again, it was okay. What do we know about these dinosaurs now that we have better understanding, better specimens, more context, since they were first kind of described, and then what can we talk about in terms of the ages, better age constraints, and what does that mean about the evolution of that lineage around this mass extinction at the end of the Triassic.
Interesting. Is there anything that my we talked about this before. My whole goal for these segments, for these podcasts, is to help students just kind of realize that there are different pathways throughout just life to get to a STEM career. What kind of aspects were really big aspects that you learned, not maybe about paleontology through your PhD program, but just about how science is conducted, or how to get through a PhD program, or what advice would you give to somebody that would be in a program that you went through?
That's a good question. Unfortunately for my staff and interns, I'm sure I'd probably give way too much free advice, and now I'm like speechless. I would say keep that one of the most important things is to keep your mind open to being wrong or not knowing something. So like, I think it's really important that, especially early on in your career, or you're just starting your career, you're going to have a lot of hypotheses or thoughts or beliefs or opinions or whatever, however you want to phrase it, whether it's in a scientific lens or not. And it's always important to know or keep in the back of your mind that you could be completely full of it, right? Like you can, one new data point, one new fossil, one experience, one person that you meet might completely change how you think about something. So when you go into something like grad school, it's a lot of like fire hose information when it comes to your classes that you're taking. You're also trying to figure out how to do your independent research at the same time that you're probably TAing or even teaching a class. And so it's just important to keep that mind open and to new things. The other thing that I'll say is that I learned real quickly that writing is one of the most important things you can do as a scientist, because it's the only way that we have, in terms of like the literature at least, to express our results or conclusions that's peer reviewed. Obviously there are outlets like podcasts or exhibits or other important things like going to classrooms and giving talks and going to the mall with robotic dinosaurs and talking to children, right? Those are important things too that scientists need. But if you can't put what's here onto a paper, onto a page, then it's really, really hard. And so I was given the advice one time: write something every day. Take 20 minutes, that's it, and write something. Whether it's the result or the methods on your paper, whether it's literally just writing down your reference citations or taking a bite out of the introduction. Just put something on the paper every day. And it's really hard, and it takes intention, but it keeps everything right here in the front of your brain. and helps you exercise that muscle. And then the third thing,
Mm-hmm.
here's the last thing I always tell people: if you go into grad school, make sure you take time to do anything except what you're there to do. Like, there are people who, and I had a lot of my, uh, lab mates or office mates, and they'd be in the lab in our office until 9, 10, 11 o'clock at night. And, that's what worked for them. That's fine. But I know about myself that I need to turn things off sometimes, and I need to go out and have a refreshment with my friends, or go out and walk in the woods, like what, I don't know, the kids say touch grass these days or something, but like,
Yep.
yeah, like do something other than think about paleontology, like turn it off sometimes. And one of the things that I realized, like one of the things that attracted me to this job was that because of the bumpers around being a federal employee, I get here at 8 o'clock and I leave at 4:30, and I don't get paid to work after dark. Like I can't. That I legally cannot work and not get paid for it. So let's find something else to do, right? So I'm tying fly fishing flies, or playing with the dog, or making dinner for my wife and I. Like, it's really important, especially early on, to disconnect sometimes and step back and say, okay, I did a good day at work. Maybe I did not solve world hunger or figure out what Dilophosaurus really looked like, but I need to step away from it today.
I love that. I preach to my students that it's about balance and finding balance in everything. And you're not going to have balance every day, but
Yeah.
the pursuit of the balance
Right.
is very crucial. I loved everything that you said there. I'm not going to try to add to anything, because I think that the three aspects were very important. So the one thing that I do want to talk to a little bit more about, if you're okay with, so you obviously you got your PhD. And then you got an internship with the Park Service, with the Petrified Forest.
Mm-hmm.
What did that look like? I know you talked a little bit about that on the last podcast you were on, but I'd like to kind of jump into what that kind of looked like. I know you said you talked to somebody at a was it the Society of SVP? Was it an SVP conference that you talked to and you initiated that?
Yeah, so I was still a master's student in 2012, which was when I would have met my now boss Bill Parker at SVP, and I can't remember which meeting that was or where it was. But anyway, one of my good friends, Matt Brown, was at the vertebrate paleontology lab in Texas, and he had actually worked out here. He had been a fossil preparator. Actually, there's a guy named Kenny Bader who's there now, and was also a fossil preparator here at Petrified Forest. So he was like, you should see if they offer internships. You should see if they have an internship. It's like, okay. So Matt introduced me to Bill at SVP, and he said, Bill, do you have any internships? He goes, yeah, I think so. And would you be interested? And like, sure. And I mean, that was how casual it was. At Petrified, we kind of do our own internships where we'll pay for housing for those interns, and then our museum association provides like a weekly meal stipend. This is different than a lot of other paleo internships in the Park Service, which used to be called geologists in the parks. Now it's all scientists in the parks, and that's sponsored by the Park Service. We do our own thing because that's what's worked in the past. And so in 2013 I did, and 14 I was an intern. 2015, at that point I had got my master's and was a PhD student, and got hired as a seasonal employee out here. And then 16, the park got money to do a 3-year inventory of newly acquired lands, so a paleo inventory. So that's when my wife and I moved out here full time in 16. So and then 2019, then I became the lead paleontologist. So I've been here. I'm now actually one of the longer term folks at the park, which is kind of strange because I'm only 37 years old, but I'm like, back when it was 2013. I'm like, wait, stop, don't do that, don't be that guy. So
Yep.
yeah, that's how long I've been around, apparently. I,
I I started, so I'm sure I know we follow each other on socials. I'm sure you know that I stepped away from teaching this year, but the past couple of years I felt like that person, like I was becoming the old veteran, and I'm like, what? When did this happen? I was the young guy a couple of years ago. Now I'm the veteran. Like, when
yep,
did that happen?
yep.
So this next question might be I don't know where it can go, but I always like to throw this out. What's a challenge that you maybe faced through all of your education, from your undergrad to your master's to your PhD, your internship, and now at the Petrified Forest? What's maybe a challenge that you've had to overcome, or something that you just maybe didn't expect in this pathway into science?
Um, so there's one of the major challenges, and obviously this is not something that hopefully most people have to figure out, but I was diagnosed with Crohn's disease when I was in high school. And this is around the time where some of like the biological treatments were coming around, but not really well tested yet. So I was taking like, even when I started grad school, I was taking 20 pills a day over 4 intervals, and it got to the point where like I would forget some and eventually just stop taking anything because I was feeling good. But grad school is apparently very stressful for you. And stress is my kind of, even worse than eating a bowl of lettuce. Stress is really a big trigger for my guts. And so when we moved out to Holbrook here, there's 5,000 people in town. We moved from Austin, Texas to a place with 3 stoplights and 1 grocery store, and I was in a just really bad way with respect to my gut. So anyway, fast forward, I got 18 inches of my intestines taken out, and I feel great, and now I'm much better at taking my medicine. But I had to learn a very important lesson, and that was like I talked about earlier, is like, you really I have to step back. I can't. There's too much in this world that's going to be stressful, and if I can manage as much as I can, that's going to be more beneficial to me. So I had to I took a whole year off as a PhD student because I couldn't work. I was out here, right, doing a full-time job, also going home and trying to write my dissertation, and so I took a year medical, and so it just taught me a lot about boundaries that I need to enforce for myself, and stress management, and B, like, what's important, right? Like, yes, I love paleontology, but I'm not literally going to let it kill me. So again, it goes back to, I'll do anything but paleontology on my time off, and I still manage to get done what I want to get done, and I'm still passionate about it and love what I do. And I learned a tough lesson, and it cost me 18 inches of the back end of my small intestine, but you know what? That's what happens sometimes.
So first of all, I want to thank you for being so open. I think it's something that I hold dear to myself, is being open with students. I think that's where you gain a lot of students' trust.
Yeah.
But I think it's also just really important for students to listen to these aspects of scientist life, where yes, like you said, taking a year off, sometimes you need to do that. Sometimes, like you said, you need to set boundaries, and you need to do what's best for you. And a step back doesn't mean there's not going to be a step forward in the future.
Right.
So I just absolutely say thank you so much for that response.
Yeah, no problem.
Yeah, that's I just think one of the reasons why I record these and I talk to students, and I try to just educate students, is they think that scientists are these like super people and you know they're invincible, and it's like, no, you talk to every scientist and they have their challenges, and they have their you know aspects of their life that they are working through. So I think it's important for them to see that, to understand, yeah, that can be me in the future.
Yeah,
So yeah,
totally.
I'm sorry, I love hearing that.
Yeah, absolutely.
So I'm gonna jump into the career aspects now. What does a typical workday look like for you at the Petrified Forest? And again, I know you talked about this on your last podcast, but I love hearing this.
Sure. Yeah. So it looks very differently depending on the season. So this time of year, um, I'm in the office. I'm writing papers. I'm doing hiring. I'm writing proposals for funding. I'm helping the museum staff prepare fossils or curate them or house them, or even doing accessioning and cataloging, um, data generation, taking photographs. Again, mostly a lot of writing and reading and catching up on like annotating field notebooks, making sure those data are captured in certain places on spreadsheets and databases, captioning field photographs. And then, yeah, there's all these other things too that I do the research permitting. So if somebody wants to come, like in a couple of weeks, we have somebody coming to measure the length, the width, and the cardinal direction of some of the logs out at the Black Forest. And so, that's happens in wilderness, but it's a scientific study, so it requires a permit. So I help do the permitting. We have trespassed livestock in certain places of the park because the fence is down. So I'm doing things like minimum requirement analysis for wilderness, because you can't drive a UTV with fence materials through the wilderness unless you dot your T's and cross your I's. And then anything that happens that costs federal dollars, uses on federal property, or where the agency is like a part owner of the project, requires cultural and environmental compliance. So I work with our archaeologist who does the cultural stuff. I do the environmental stuff to mitigate impacts and make sure that we're taking care of the resources that we're trusted to take care of, not just the fossils. In the summer is when we do most of our field work, and yes, it's hot, but that's just when we do it. Part of that is because a lot of my staff or interns are students, so that's when they're available. Some of it also is that, to be honest, we're a mile up. We're the same elevation as Denver. So it gets cold during the day, and plaster doesn't always set in winter. And the sun is at such a southerly angle that it really throws off search images for fossils in the wintertime. It's right overhead in the summer. It's much easier for some reason to find stuff. But again, if I collected every fossil that I ever tripped on out here, we would fill up the collection in 2 weeks. So, it's not like I have to do field work 365 days of the year. I can, and I'm out there all the time, but summer is when we do most of our work. So again, a typical day, get in, we'll, grab the truck keys, drive out to some spot that either we're inventorying for the first time, or we're going back to one of the 1,000 documented paleo sites in the park to do some monitoring. We collect scientifically or educationally significant specimens, because NPS policy basically says if you find something like that, you have to preserve it. And there's 2 ways you preserve it. One is you build a building around it, like Dinosaur National Monument. And 2 is you collect it and you take care of it in a museum collection. So, we're out there doing that work and making those judgments. If it's raining, and it tends to do that in the monsoon season in the summer out here, then we're in the lab doing molding, casting, prepping. I mentor my interns and seasonal staffs on independent research projects that either they can present on at SVP or turn out as a peer-reviewed article. And then all that compliance and permitting stuff is year-round, so I do a lot of that too. But was really fortunate here at Petrified Forest because we're well encapsulated. We can do nearly everything from discovery to housing and curation seamlessly in one spot. No, we don't have a CT scanner, right? But like yet, maybe we'll get one.
Yeah.
But a lot of my colleagues have to plan their field work and their whole year well ahead of time. Like I'm going out to northern Arizona for 3 months, and we have to get as much work as we can do, at that time. And we're here like, well, it's a nice day. You want to go out in the field? Yeah, sure. And, and at the end of the day, I go back and I sleep in my bed, and not, I love being outside. We've demonstrated that, but there is something to say, like being able to just get up in the morning, drive out to the middle of nowhere, find a super important fossil, collect it, bring it back to the lab, and see to it that it's getting taken care of, and then go back to your house at the end of the day. Like it's a really unique opportunity.
That's I for those that don't know, that are watching this, I do a little bit of field work in the summers too, and I always try to schedule a couple of days when I get back home just as rest, because sleeping out in a tent for a month can be tough. So I love hearing that you have that experience of like, oh, I can go home and I can get a good night's sleep, because field season is tough.
Yeah.
So that's really cool to hear.
Like I said earlier, I spent 11 weeks straight in a tent. I know what that's like. You're like, yep. One shower a week, whether you need it or not. Sure. Yeah. Like
that's yeah. It's a rough life, but it's one of those. I was talking to a bad ecologist, and she talks about field season being like the second tier of fun, where it's like it's fun to look back on, but it's not really like totally fun while it's going on. It's like, yeah, that's tier 2 fun.
Yeah, I got
one of the questions I
got shocked by lightning when I was in Rudyard, and so like that's the kind of thing where it's like, yeah, that was terrifying, but looking back,
it's a good story.
Yeah.
I have to ask this, and maybe I'll cut this out. Did you ever go to the because I was in Rudyard. I think you sent me a message while I was there last summer. Did you ever go to the bowling alley / bar that's like the only place to get? Oh man, yeah. That place was just, it was amazing. I love going there. It's almost like a time capsule.
Yeah, I mean, all that whole High Line from like Havre to, oh my god, yeah, it's like stepping into a different planet, but it's gorgeous, absolutely gorgeous. Did you meet Dan and Lila then? Yeah.
Yep. Okay. I stayed with them. We worked. Ben Rotenberg and I. He was the lead at our site. We were working on maybe a new. I think it's a Tyrannosaurus species. Maybe they're trying to figure it out. I was there with Dr. Woodward as well. So yeah, that place was beautiful. I'm gonna kind of dive a little bit into what is it like being a paleontologist, at a national park service versus like a paleontologist that might work for a museum, or I don't know if I want to ask this part, but like a private, I don't want to say private, but just a regular paleontologist. What is the dynamics that are different at a national park service?
So, what I do is very similar to what a museum curator would do in terms of like making collections, supervising that, their care, and then doing, research and providing some kind of outreach component. But the overlay at the Park Service specifically, and this is different than like if you were a paleontologist with the BLM or the Forest Service, is that we have that mandate of protect and enjoy, or, it's the Organic Act. So our job is to figure out how we can protect the resources, but also make sure that they're available, and everything that we are learning about them is provided and digestible to the public, right? So, day to day, that looks like, oh, should I collect that phytosaur tooth or not? Well, is anybody doing research on phytosaur teeth? Is this one in particular important, or can it be put back down on the ground for somebody to enjoy on their hike, right? But then on the back end of things, when it comes to like our research, yeah, we'll sit down and type out, about the post-zygos spinofossil, whatever, of a sauropodomorph neck, and you can say that to a visitor, and then you'll see the drool coming, and you're like, okay, but our job is to figure out how to make that accessible, right? Because this stuff is, the park is the size of the city of Chicago, and just telling that to the public is like, whoa, that's your land, and it's full of fossils, it's full of cultural, history, 13,000 years worth of continuous human habitation. It's one of the best examples of shortgrass prairie ecosystems in the American West. And so there's so much to see here and to observe and be a part of. Our job as resource managers is to protect them, but then also put them out there in a way that the visitors can enjoy, whether they're here or whether they're searching on Instagram, or whether they're on our website, or whether they're looking at the scholarly works that we're producing. That's the overlay that the Park Service has, that's not other institutions or other types of paleo jobs don't usually have.
Interesting. I love that response. So my next question is going to be kind of more about your I would say your research, but your fossil finds. What would you say would be the coolest fossil find or paleontological find that you've been a part of at the park?
Oh man, it's hard to say one. I'll say two things. One is we've been focusing a lot on the microvertebrates of the Chinle Formation. So these are things that, I'm 6 feet tall. So if I'm walking the Badlands, I would never see them if I wasn't, literally nose to the ground looking for them. So we're sampling these things in bulk and then washing them through screens in the lab and then picking them under the microscope. That's a fish scale. That's a reptile jaw. That's coprolite. That's a rock. That's a rock. That's a rock. That's a rock. So one of our sites is low down in the formation. It's actually pretty old, about 120 million years old. Some of the oldest rocks that we have here exposed at the park. And we've collected and screen washed nearly 2 tons of it. Like more than 2 tons, about 4,500 pounds. And so it's an incredible record of the small-bodied organisms that are in this basically pondatum. If you go out, and I ask your viewers not to do this, but if you go out and kill everything in your backyard, right? Most of it's going to be small-bodied organisms. Most of the biomass and the biodiversity in any given ecosystem, aquatic, marine, terrestrial, whatever, are going to be small-bodied organisms. And that's true in the Triassic. So we're trying to really, it's easy relatively to walk around and find these, phytosaur skulls that are 3 feet long. It's far more difficult to find the earliest lizard, with jaws this big. So one of the coolest discoveries we published on in 2023. I remember coming into work one day, and my seasonal employee and one of my best friends, Ben Kligman, was under the microscope, and he's like, "Adam, come look at this." He's like, "What do you think this is?" And I'm looking under the microscope, and there's a little jaw, and it's, no bigger than the tip of my, clicky end of my pen, and it's got 2 rows of teeth on it, and it got a little gentle curvature. And I look at him, I'm like, "Ben, is this a Sicilian?" He's like, "Yeah, I think so." Oh. And I'm like, "Wait, this is from our site?" He's like, "Yeah." And it turns out, it's the oldest Sicilian in the fossil record. And now we have 100 of those lower jaws. And here's the kicker. I think all but 2 of them are from the left side. Obviously, just like most vertebrates, you have, your mandibles are symmetrical, and you have a left one and you have a right one. And 97 of these things are from the left side. So tell me what that means. I don't know. So anyway, we published that in Nature, and that was really cool. We call it the funky worm, and its genus name is Fungus vermis. You can see big into 70s funk. So the Ohio Players had a song called "The Funky Worm," and obviously Sicilians are not worms, but they would have looked like worms, and they still do look like worms. So we after we figured out we had these things in the site, we go back to it and we play the Funky Worm at the beginning of every field day, and summon the Sicilians from the Triassic. But then the other cool thing that happened this last year was actually I was out with a group from Baylor at one of our sites. There was a student who was interested in doing some stratigraphic work on some of the paleosols and channel sandstones in the Triassic, and so we were out there and kind of showing them around. And one of the groups of students who was just kind of there, as a field trip, found some bone eroding out of a small little hill, and so I documented it, took a bunch of photos, put a bunch of glue on it, put a bag over it, piled some rocks on it, and was like, we'll come back and check this out. And so I didn't actually get out there till 6 months later, and this was my seasonal Alaska and I last summer. It took us about 5 minutes to uncover the maxilla of something, and it was teeth like this in place. And we're like, oh my god! I mean, the whole time we're like, oh my god! And the hilltop is so it was so friable that we weren't even using tools. We were basically using our brushes and blowing. It was like as close to the Jurassic Park excavation I've ever seen. We were like, and then there's a complete jaw, and we're like, whoa! And so I found right away that it's a Rauasuchid, so it's like Postosuchus. It would have looked like a T-Rex in the Triassic, but it's different lineage. And so we have now most of the skull of this thing that's associated, and we spent the rest of the summer essentially digging it up. Turns out one of my colleagues, Sterling Nesbitt at Virginia Tech, was at the same site in 2006 and had found a Rauasuchid dennary. And so this thing's already cataloged. It's already got object. It's in our collection. So this year we found the other dennary and then the rest of the skull. But it goes to show, I've been to that site every single year since I've started here in 2013, and there's never been anything coming out. But that one rainstorm just before that kid showed up eroded just enough that it exposed that, and that's how these kinds of crazy discoveries are made. So, I mean, there's 2 Postosuchus specimens from Post, Texas. There's a Postosuchus from North Carolina. So this is like 4th, 5th, depending on how you're counting them, in North America.
That is amazing. I love that hearing paleo stories like that, because I feel like a lot of it can just be luck sometimes, where like you said, the one rainstorm just enough where it didn't destroy it, but I think and maybe I'm misremembering this. I remember on your Instagram story once, where you found a piece of bone that matched with another piece that was found years before. Was this any part of that story?
Yeah.
Or am I misremembering this? Was this you?
Yes, that was the same. It's actually associated with this Postosuchus. So there's 2 quote unquote sites in that same spot. So there's this big broad basin where I'm pretty sure the fossil layer has eroded away, and everything is on the ground that's eroded. The fossil layer's eroded down. It's gone, but the fossils are still there and are disintegrating essentially. So you go out there every year and pick them up, and oh, there's a lungfish tooth, and so and then there's this little mound in the middle of that, which is the only part of the remaining fossil layer, and that's where that Postosuchus was from. But to get from the truck to there, you have to walk through this big basin of eroded fossils. And again, I've walked over that dozens of times. And coming back from the Postosuchus site, I look down and there's a Chindisaurus femur head. I'm like, oh, it's Chindisaurus. Glad I did a dissertation chapter on this thing. And so I'm like, wait a minute. I recognize the broken end of that. And so I came back to the collection, and I opened up the drawer of Chindisaurus, and I found where that site was, and sure enough, there's a femur segment and then go click. And that thing had been collected in like 2007 or 4, I can't remember. But it's just been sitting out there since then, and it fit perfectly. Like like nothing was broken. It just like literally went boop.
I remember seeing that in your story and being like, "Oh my gosh, that is so cool." So I'm going to ask just a couple more questions. This question's kind of an odd question, just because I always just like to hear about science through other people's shoes. So obviously, I have my pathway through science. I was a science teacher. I got my undergrad in biology. I have my understanding of what science looks like, what it looks like to me. What is something that I could maybe learn about science walking through your shoes or through your experiences?
So I'm on the board of directors for the Flagstaff Festival of Science. So it's a 10-day festival in end of September that provides like 100 events, whether they're hikes or talks or workshops or experiments, and it's very much oriented towards families and kids, but it's just all ages. And so we try to make science accessible as much as we can and free. And so one of the things that I always try to emphasize is that science is not a noun. It's a verb. Like it's an action you're taking, right? So there's a lot of folks I feel like are intimidated. Oh, the scientists think this, or this data say this, and science is like this monolith of, oh, that's science. But science is just a way of figuring stuff out, right? It's a method. It's a process that you either support your hypothesis or you don't. And it's a way of trying to answer questions about the natural world that, like we said earlier, sometimes it answers your questions and sometimes it just leads to other ones. But I always try to put that in perspective of people. Science is not immutable. It's a labile thing, right? It's flexible, and it's built to prove yourself wrong, right?
Mm-hmm. Mm-hmm.
Yeah.
I love that answer, and I actually had what you're saying. So I love that we agree on this. In my classroom, I had science as a verb above my hood, and so my students would, when they would ask about that, I'm like, hey, it's like you said, it's a never-ending cycle of trying to disprove yourself almost all the time, and it's I love that answer. That's amazing. You talked about all the research. I was looking at your profile today online, and there is so much research that I feel like you're either leading on, you contribute to. What is an aspect of writing, or you talked about a little bit about building the skill of writing, but what's an aspect of just producing that amount of research, that data, and publishing it? What's something that you've learned about that whole process?
It's a good question. I really enjoy helping people learn and walk them through that process. Like, one of the most fulfilling parts of my job is the amount of work I get to do with staff and interns, and because I was given that opportunity so many times, I like being able to provide that for others. But when it comes to research, I'm like, my boss and I joke about, like, we like doing Sesame Street paleontology. Like, one of these things is not like the others. Like those, it's nuts and bolts in terms of what I enjoy doing. Description, anatomical descriptions, taxonomy, evolutionary relationships, age differentiations in terms of geologic ages. I have colleagues who are much more quantitative and like the back end of things, and that's great. But what I've learned about myself is I'm a tactile learner, I'm a visual learner, and so that translates into what I tend to like working on. And I just like working with the object itself, right? The primary information is that bone, right? Or is that rock. And so that's kind of what has motivated me in my research direction.
All right. So, what is something that you wish people, when visiting the park, would ask you more about either the park or your job as a paleontologist?
In general, I join the rest of the staff here and just trying to get people out into the park. Um, for a long while, based on maybe some unfortunate misguided information, a lot of the members of the public were treated as potential wood thieves, right? Like, here's a wayside where you can stop and take a picture. Here's a trail where you can get out and walk on. There's the gift shop. There's the exit, right? And so we now have known through things like repeat photography and just talking to folks that very small amount of wood leaves the park every year. Not nearly as much as the several tons that were thought of at the time. So we are really, really trying hard to make opportunities for the visitor to engage in their park personally. Maybe all they want is to drive through, and that's fine. So we've given them an audio tour that they can put on their car and drive through. But maybe they want to spend a couple nights in the backcountry, and so we make sure we're trying to push those wilderness backcountry passes, or we're creating off the beaten path hikes. We're creating things like our Field Institute, where you can come out and be a member of my crew for a day, or go out with the archaeologist and spend an overnight looking at petroglyphs under the Milky Way. We're really, really, really trying to get people to go enjoy the park in a way that they haven't before. Even our local community in Holbrook, a lot of folks are like, "Oh yeah, I was out there in third grade for a field trip." I was like, there's a lot to do out there. So we're really always trying to get the visitor to appreciate more than what they think they're expecting when they come here. Does that make sense?
Yes. Absolutely love that. Yes. Well, I think this is a great point to wrap today up. I just want to thank you again. I know, obviously, we talked about how busy you are with all of your duties as a park employee, but also as a lead paleontologist. So I just want to say, from the bottom of my heart, thank you for taking this time and just working with me, talking with me, and being a resource for students. Is it okay if I put some of your contact info on the YouTube description for people to maybe contact you a little bit?
Yeah, my email address is great. My phone number is not working because the phone lines got cut during some renovation project, but the email will get people to where they need to be.